Hello everyone, welcome back to Code New tutorial. So for today, I'm going to focus about first normal form, which is the first stage in normalization. So when we talk about first normal form or 1NF, this is going to guarantee that all fields in our tables must be atomic values. And secondly, we'll have to make sure that the repeating groups are removed and eradicated or at least avoided. And then null values are prevented. And then the last one should be the all of our tables must have primary keys. Okay, so let's start with this table's TBL owner that we have right here, which has fields like ID, name, gender, age, contact, email, and so on and so forth. And with the records in it, so we have like more or less 8 records. So we'll have to make sure that in step 1.1 in uh, first normal form, we'll have to again make sure that all of our fields must be atomic. So among all in our fields, we can actually observe or notice that there are non-atomic fields, particularly in the address. So in the address, we can actually split this into different fields because address could be divided into street, into city, into country, and into zip, and even province, and even barangay or purok. Okay, so that is why we'll need to make sure that uh, this address field should be split into 2 fields. It could be like street or barangay, and we can actually uh, split them further, but we will stop from there. Okay, from here. Next is another one is we have also here fields that have 2 values, at least 2 values. Okay, particularly in the contact, in the email, okay, in the pets, which we have here for ID 101, we have 2 contacts. For email, we have also 2 emails for that record. And for the pets, he has actually 2 pets. So we'll have to split them up by okay, of course, splitting the 2 fields. I mean, 1 field into 2 or more different fields. So this time we have now contact 1 and contact 2. We have here the email 1 and email 2. And for the pet, uh, we can actually have a separate discussion on that. So this time let's focus on the contact 1 and contact 2 and email 1 and email 2. Now, in some cases, though you are able to split these fields, there could be problems that this table might encounter. Example, if let's say you want, or let's say an owner or a person has 3 or more contacts. So let's say he has token text, he has globe, he has D2, and he has TM, or even he has probably pwede na naa siya PLDT contact number or something like that. Or I, for myself, I mean, personally, I have actually a lot of emails. So I have personal emails, I have for work emails, and I have for other emails, for to some sort of like for for other business purposes. Okay, so in such, if that will happen, what if, okay, what if there is, or a person, there is there are actually some persons here that does not have, or parang wala silang, probably they don't have that much of contacts or emails. So this would generate null values to that particular table. Or probably if you have, let's say, a person will have 4 contacts, so probably you will add contact 1, 2, and another 2 fields, which are contact 3 and contact 4. And that is not a good idea. So as it is actually going to create more null values. As suggested in the 1.2 first normal form, we'll have to avoid null values. And yes, every time we create, okay, every time we create uh, contacts or fields for additional fields for contacts or for email, it will just create null values. Okay. All right. So now next is to avoid that, of course, we'll have to remove the our day. I mean, we'll have to decompose our table into three or more different tables by by creating another table out of this particular table. So how do we do that? So we'll need to create a table, let's say for um, owner and contact table. So we have now owner and contact table. And as you can see, owner ID 101 has two contacts, which are this ID contact ID 1 and 2. And owner ID 102 has also two contacts, the same with 103 and 106, while the rest has actually has only one contact. Okay, so now if as you can also notice that we assign a primary key for our contact table. So ID 1, 2, 3, 4, 5, so on and so forth. And then why not contact number, or the contact is our primary key for this. So we cannot make this contact to be primary key because contact is going to change over a period of time. Okay, so the idea of primary key is that it does not change and it must be unique. Though contact number is unique, but it is going to change over a period of time. And you're going to change probably contacts after 5 years, after 10 years, or probably after just a few months. Okay, so and that's not a good idea to make contact as our primary key. That is why we have to decide a primary key for this table, just for us to create relationship between these two tables. And that key, or that is actually, and that one is actually called a surrogate key. If you cannot decide of any primary key for that table, just like for this contact, then you can assign surrogate key for this particular table. Okay, and because you want to create relationship between these two tables, so by creating primary key and foreign key, so we have here the primary key. Okay, so we have the primary key owner ID, and then we have the foreign key in our contact table. So there, both of our tables have now primary keys for owner ID and for ID. And for us to relate the relationships or relate the two tables together, we'll have to create foreign key in the contact table. All right, next is, okay, another one is the same thing or the same process we apply to email. So just like what we have right here. So since owner ID 101 has two emails, the same with 102 and 105. So we'll have to create another table for the email, and we'll create another uh, another table email. And also notice that since the pet is also a non-atomic, we'll have to create another table for pet, and we'll have another separate topic on this pet table, and because we're also going to normalize this table. But you will have to notice here that this table that you have right here, which is the owner ID, is actually related to our pet ID. Okay, so yeah, that's it. Now, next is notice also that pet 108 does not have does not own any pet. So at least we avoid null values to that. So if ever we are going to add new values, let's say 12, and then you have an owner, new owner, and that owner, but I mean that owner doesn't own any pet yet, then therefore um, you just don't relate that particular owner to the pet table. So there, you are able to avoid null values. Okay, next is 1.4 or step 1.4, which is remove repeating groups. So when we talk about remove repeating groups, obviously in our table TBL owner, we have actually fields there that has repeating fields that have repeating groups, particularly gender and civil status. So with regards to age, although age can be considered as repeating groups, but it is actually not a good practice, or it's not a good idea to treat that as a repeating group, because it's normal that we all have the same values in our ages, the same with the name. But with the gender and civil status, we only have limited time, limited value. In fact, for gender, at least we have two, or if you want to include LGBTQ, lesbian, or bisexual, then you can have that one in your table separately. And for civil status, you have single, married, and widowed, and yeah. So if we want to eliminate the repeating groups with this table, then we'll have to decompose the table into three tables. So from here, you are now going to create a table civil status that will handle store only status, and we are going to create surrogate key for this one, which is civil status ID. The same thing with our gender ID, which is we have only one male and female, and this would guarantee. Did you know that this would guarantee referential integrity? That when upon storing record to your database or to your table owner, you cannot add any value that are not present to gender table. So meaning to say, you cannot assign to this table any value that are not stored in the gender table, which are male and female. Okay, if you want to assign another value to it, then you'll have to store, or you have to add or insert another value here. Just like for instance, let's say you are going to include here lesbian. So, and then you will add another value here or record here, and then put here like for let's say lesbian is primary Kenya is ID3, then we'll have to put here 3 or something like that. The same thing with the civil status. So again, because for civil status and gender, we have only finite, I mean, specific values to this particular table. So that is why we can actually you can actually decompose this to another table. And also, did you know that if you're not going to separate this into another table, just like though for male, no, we can have here one for male, or one for two for female, or let's say M for male and two for female. That is actually saving memory space. It's okay, but it's again, it's your discretion to do that. Okay, but as suggested in the first normal form, we'll have to remove or eliminate repeating groups. So in the same with the we have here civil status. So you have single, married, widowed. So the best thing about this this idea of normalizing our table is that, let's say for an instance, you have 1 millions of, well, let's say 1 million of records in your database or in your table for owner only. And then you'll have, let's say, half of the population is, let's say, a male, and then let's have a female. So take note that any string or a varchar is actually considered as 8 bytes. So meaning to say, if you're going to store male, female here for each of the record in your table, and that's let's say 1 million. And remember, one byte is 124. 124 bits. No, one byte is equivalent to 124 bytes, and that's multiplied to 1 million bytes or 1 million records, and that is really a lot. It's meaning to say it's going to actually consume a lot of space in your disk storage, because again that is necessary because one value for a string or a varchar is actually equivalent to 8 bytes. And assuming you have 1 million of records there that has male and female, so you're just going to multiply that with that values or that number of records, and that is really a lot. Okay, the same thing with this one. But with this kind of, or with this solution, you are actually able to reduce the space complexity. Why? Because even though you have 1 million records here for your owner with a gender ID 123, remember that all those records relating to one value are has only one instance, which is a male, and all those assigned to two has also one instance, which is a female. So therefore, okay, instead of multiplying 8 bytes to each of the record or row in our table, you don't do that because there's only one instance of male that is actually 8 byte, and for female that's actually 8 bytes, so you only have 16 bytes. And since you just use number here, and let's say if you use tiny int for this one, so you don't actually consume much memory or much space in your computer. The same with the civil status, because again this will be repeatedly, and we the instance could be single, married, without, single, single, married, without, and why not put that in a separate table, and then at least there's only one instance relating to it. Okay, another would be let's say if you are working on with enrollment system. So in the enrollment system, you might have tables like student, administrator, cashier, and of course employee and students. If you have those tables which are a person's, most probably you're going to get the uh, data from them for civil status and for mail, and it's going uh, to be stored repeatedly. So a male for student, female for student. You do that for employee. You do that for professor or teachers. So why not create a single table and just relate it to each and every table that is going to relate on that particular table. So like gender, pwede siya ato sa student. Gender, pwede siya mo ato sa professor. Gender, mo ato siya sa employee. And gender, pwede siya mo ato sa cashier. Okay, so that's one of the things na important why we'll have to remove repeating groups. Okay, so I guess that's all for first normal form. So thank you and have a great day ahead. See you guys in the next normalization stage. Bye bye.